Myself Binoy Poyili, Assistant Professor, Department of Mechanical Engineering, Vedavyasa Institute of Technology. The topic is turbojets. This is a representation of turbojets. This includes an introduction, primary components of turbojet engine, afterburner, thrust reversers, working of turbojet engine, principle of operation Brayton cycle, merits and demerits, and applications. The turbojets are the oldest kind of general purpose jet engines. The turbojets are rotary engines that extracts energy from a flow of combustion gas. They produce thrust by increasing the velocity of the air flowing through the engine and operate on Newton's third law of motion. That's for every action there is an equal and opposite reaction. This is a representation of components of the primary components of a turbojets. They are air intake, compressor, combustion chamber, turbine, and a nozzle. Air intake. An air intake aims at bringing large amount of surrounding air into the engine. A tube-shaped inlet like one you would see on airliner, usually of cylindrical or conical design. The inlets come in many shapes and sizes depending on the aircraft. The compressor. The compressor rotates at very high speed, adding energy to the airflow and at the same time squeezing it into the smaller space. Compressing the air increases its pressure and temperature. The compressor is driven by the turbine. The compressors used in turbojet engines are mainly classified as axial flow compressors and centrifugal compressors. The axial flow compressors. The axial compressors are rotating airfoil based compressors in which the working fluid principally flows parallel to the axis of rotation. Axial compressors consist of a shaft that drives a central drum which has a number of annular airfoil rows attached. These rotate between a similar number of stationary airfoil rows attached to a stationary tubular casing. A pair of rotating and stationary airfoils is called a stage. The cross-sectional area between the rotor drum and casing is reduced in the flow direction to maintain axial velocity as the fluid is compressed. The centrifugal compressor. The centrifugal compressors are rotating airfoil-based compressors in which the working fluid principally flows perpendicularly to the axis of rotation. The centrifugal compressors consist of a shaft that drives an impeller which has a number of curved blades. The impeller rotates in a casing which is designed to convert the kinetic energy of the fluid into pressure energy before leaving the compressor. The combustion chamber. In a turbojet, the air and fuel mixture passes unconfined through the combustion chamber. As the mixture burns, its temperature increases dramatically. The combustion chamber is usually in the form of cans, which comprise the fuel injector and flame holder. The turbine. The hot gases leaving the combustors are allowed to expand through the turbine. The turbines are usually made up of high temperature metals such as inconel. The turbine's rotational energy is used primarily to drive the compressor and other accessories like fuel, oil, and hydraulic pumps. In a turbojet, almost 2/3 of all the power generated by burning fuel is used by the compressor to compress the air for the engine. Nozzle. After the turbine, the gases are allowed to expand through the exhaust nozzle to atmospheric pressure, producing a high velocity jet in the exhaust plume. In a conversion nozzle, the ducting narrows progressively to a throat. Afterburner. An afterburner or reheat jet pipe is a device added to the rear of the jet engine. It provides a means of spraying fuel directly into a hot exhaust where it ignites and boosts available thrust significantly. A drawback is its very high fuel consumption rate. Thrust reverser. The thrust reverser is essentially a pair of clamshell doors mounted at the rear of the engine, which, when deployed, divert thrust normal to the jet engine flow to help slow an aircraft upon landing. They are often used in conjunction with spoilers. The accidental deployment of a thrust reverser during flight is a dangerous event that can lead to loss of control and destruction of the aircraft. Working. The air is drawn into the rotating compressor via the intake and is compressed to a higher pressure before entering the combustion chamber. The fuel is mixed with the compressed air and ignited by a flame in the area of the flame holder. The hot combustion products leaving the combustion expands through the turbine where the power is extracted to drive the compressor. The gas stream exciting the turbine expands to ambient pressure via the propelling nozzle, producing a high velocity jet in the exhaust plume. The Brayton cycle is the PV and TS diagram for the Brayton cycle. The thermodynamics of a jet engine are modeled approximately by a Brayton cycle. The ideal Brayton cycle comprises the following thermodynamics processes. They are the isentropic combustion process, isobaric heat addition process, isentropic expansion process, and isobaric heat rejection process. They are represented 1, 2, 2 to 3, 3 to 4, and 4 to 1 as processes. The merits and demerits. The merits of the turbojet engines, they are very high power to weight ratio, compact than most reciprocating engines of the same power rating, fewer moving parts than the reciprocating engines, low operating pressures, higher operational speeds, low lubricating oil cost and consumption. The main demerits of turbojet engines are cost, the longer startup than the reciprocating engines, less responsive to changes in power demand compared to the reciprocating engines. Applications. The Concorde. One of the most recent uses of turbojet engines was Olympus 593 on Concorde. The Concorde used turbojet engines because it turns out that the small cross-section and high exhaust speed is ideal for operation at Mach 2. The Thrust 2. In 1983, the car reached a top speed of 1047.49 km per hour and broke the record at 1019.468 km per hour. It is powered by a single Rolls-Royce Avon jet engine sourced from an English Electric Lightning. Thank you.